All right. We are recording now, hopefully. Yes. Okay, so Euler came up with 4 diagrams for logic statements. All A's are B's. So if we have a circle that has everything with B in it, it says A's are part of B. So I'm putting an A circle inside B. Do you see all A's are inside the B? Next, no A's are inside B. So I have A here and I have B here. A's are not in B's. They're not even part of it. None of the A's are in B's. He came up with 4 different statements. Some A's are B's. If I have A and I have B, do you see this is the region where some of the A's are also in the B's? And then you can write the same thing. I mean, the same picture. If I could write the picture. Some A's are not in B. And these are the A's, these are the B's. But this is the region where the A's are not in the B's. So these are Euler's 4 statements. And I might come back to these, referring to these all the time. I would write these down, especially for the homework. I would write all 4 of these down because Euler uses one of these for every problem, at least one of these for every problem. These are the only drawings that he wants as far as when you're reading these problems. So you take mental note, write them down. Look, even I have them written down. It's such a confusing section, but it really has to do with logic and not the words itself. All right, so I am going to the workbook now. All right, there is the workbook. So if we look at this, it says write a conclusion to make the following arguments valid if possible. If it is not possible, state so. All dogs are happy. Do you see the second part is the happy part, and all dogs are inside of it? Do you see? Here's the dog, the D. The dog, all dogs are happy. So the dogs are inside the happy. That's the very first one from Euler. Sam is a dog. So if Sam is a dog, he belongs inside the dog ring. You see, this is Sam because he's a dog. He deserves to be in the dog ring. It says Sam is a dog. So the statement we can make for this is since Sam is a dog, Sam is happy because Sam is inside the dog ring and the dog ring is inside the happy ring. So all dogs are happy. Sam is a dog. Sam is a happy. You can say happy dog if you want. Sam is happy or Sam is a happy dog. All right. The great thing about this test is it's multiple choice, so you get to pick the correct answer. All right, let's look at the next one. All women are honest. So this is the honest circle, and women go inside of it. All women are honest. So my question to you is Pat is honest. Where can I put Pat? This is women. Can I put Pat in here? And somebody saying, you could, but is Pat a woman? I mean, I can only put Pat in there if she's a woman. I don't know if Pat's a woman. Pat could be a man's name or a woman's name. That was a good, I think that, I mean, all women are honest. So you could put it, and let's just say Pat was here. Let's say you could put her in a man's thing, even though it doesn't show it. Men could be out here. Pat could be a man. We don't know. Do you see? We don't know if Pat is in the woman's circle or in a different circle somewhere else. The last one we knew the dog, the whatever is the dog, Sam was a dog, so he goes in the circle. We don't know Pat is a woman. So all women are honest. Pat is honest. Can I say Pat is a honest woman? I can't say that. Pat might be a man. So it says write a conclusion to make the following arguments valid if possible. It's not valid. You can't make. You can say all women are honest. Pat is. All women are honest. Pat is honest. Pat uh, is a woman. I can't say that. An honest woman. I can't say that. Pat might be a man. It doesn't say it, but it doesn't say it's not. So that I'm going to say this is not a valid statement. I cannot write anything down. It's not valid. It says write a conclusion for the arguments valid if possible. If it's not valid, possible state say it. And I think it's not possible because I don't know if Pat is a woman or not. So that's why this section I think is confusing. Uh, you can't well, you watch when we to get to the LeBron James one. That's going to be a tricky one. Okay, so all men are generous. So once again, here's generous. I'm putting men inside there. My sister is generous. Now, would you agree? My sister does not go into the men's category. But my sister could go here because she's not a man, so she doesn't go inside the man's circle. But she could be generous. It says my sister is generous, so it goes in the generous circle. So all men are generous. All the men go in the generous circle, but my sister is not a man, so she doesn't go in the man, but she does go in the generous. So all men are generous. My sister is generous. Can I say my sister is a man and generous? No. Can I use this and this? And I'm saying no. There's nothing else I can say. Uh, so it's not valid. I mean, I could say a lot of these are not valid. But you see, I can't put them in. I can't say my sister is a man and generous because she's not. It's a sister that, by definition, sister is female. Okay, so this next one, instead of all and all that, it's very similar. If I come to school, I will drive on Walters. It's kind of like saying, when I drive on Walters, every time I drive on Walters, I will come to school. So this is when I drive on Walters. I'm trying to figure out which one. See, this is one of those where it doesn't say all. So I don't know what to write because there's no other way of writing it. If I come to school, I will be on Walters. So this is Walters and this is school. So if I drive on Walters, I'm going to put drive on Walters. I will be in school. I did not drive on Walters. That means I'm over here. I'm not in the Walters circle. This is me. I did not drive on Walters, so I can't be in the Walters school. So it makes sense. If I come to school, I will drive on Walters. I did not drive on Walters, so I did not go to school. Do you see? I can only go to school if I put an X here. But I'm putting it here because I didn't drive to Walters. I can't put a dot in the drive to Walters circle. So obviously, if I didn't drive on Walters, I didn't go to school. So does anybody think this is confusing and tough? I mean, it really does. You're going to have to do this homework and maybe hit similar till you kind of like get it. It's a tough section. It's a really tough section. Watch the next one. This one has sometimes my classes arguing. LeBron James. Mm. All basketball players are rich. So rich is the second one. So we put that as a circle and we put basketball players in here. All basketball players are inside the rich circle. So all basketball players are rich. LeBron James is rich. Where do I put LeBron James? Do I
Just
put him in? Go ahead.
just in the rich section.
Yes, because it doesn't say he's a basketball player. It just says he's rich. Now, a lot of people says, "Well, we all know LeBron James is a basketball player." What if this is a different LeBron James? What if this is a short, uh, heavy set guy that, that doesn't play basketball, but he has the name LeBron James, and people often get him confused for regular LeBron James on the phone. So this is LeBron James. He's rich, but it doesn't say he's a basketball player. So all play basketball players are rich. LeBron James is rich. So I mean, in reality, we should say LeBron James is a rich basketball player, but we can't say that because we don't know if he goes in the basket. If this particular LeBron James goes into the basketball circle, it doesn't tell us to do that. It just says put him in the rich circle. So we cannot say it. So this is not valid. I can't say LeBron James is a rich basketball player because it didn't tell me to put the dot in the basketball circle. Okay, the next one, no cats are dogs. So remember the one of Euler's things saying no cats are dogs. That means they separate and they don't touch each other. That was one of Euler's things that started with no. Prissy is a cat. Prissy is not a dog. Can I use cat and dog in the same sentence? Yes, because Prissy is a cat. Chrissy is not a dog. That's supposed to be a D. Chrissy is not a dog. No cats are dogs. Prissy is a cat. Prissy is not a dog. So that's how I would write that one. All righty, let's move on. It's a really simple, short section, but it's crazy, I think. Okay, so we want to actually try to draw Euler's his four diagrams that we wrote down, and whether the argument is valid or not. Some roses are red. So some are red. If you look, those are the some looks like this. And we're going to call roses and red. So do you see right here? Some of these roses are red. Therefore, some red roses smell sweet. Therefore, some red roses smell sweet. What if I do this? Sweet. Remember, when we see some looks like this, where they cross over. And I'm saying red roses, or some red roses smell sweet. Oh, by the way, I'm gonna make this a little bit bigger. This is actually a real. I'm actually looking at this differently. Some roses are red. Therefore, some red roses. The red roses, by the way, these are the red roses. These are the red roses in here. Some red roses smell sweet. I'm going to add a circle and put sweet. Do you see? These, it says some red roses smell sweet. That's right here. These are the red roses, but these are the red dot is only some of the red roses, and they smell sweet. Okay. Therefore, some red roses smell sweet. I can draw the picture. If you can draw the picture and you can try to draw it as many ways as you want, you can try to draw it as many ways as you want. As long as you can draw one picture to disprove it, then the whole thing is disproved. But I can't draw it any other way. So I'm done. I think this is good. This is a valid statement. All right, let's try the next one. So it starts off with no rectangle is an oval. Once again, no and oval. No means they're separated. No rectangle is an oval. So that's this part. I just drew it in red. Next, I'm going to draw it in blue. All circles are ovals. So that's an oval. And here's a circle. Do you see all the circles are inside the ovals? Okay, so that looks good. Therefore, no rectangle is a circle. That's true. No rectangle has a circle in it, so it is valid. It is valid. I almost want to go back to number 7. I kind of don't like that one. I think I did number 7 wrong. Some roses. No, I did it right. I did it right. I did it right. Okay, I wasn't sure, but I know I did it right. So number 8 is valid. Let's look at number 9. All people who are not studying are asleep. So all people who are not studying. So these are the people who are not studying. All people who are not studying are asleep. So these people are sleeping. All people who are not studying are sleeping. So these are the people sleeping. They're not studying. Maria will not be asleep if she is worried. So Maria's not asleep. So Maria could be out here, or Maria could be here. These are the people sleeping. Maria could be in either location. Therefore, if Maria is worried, then she will be studying. Do you see? I could put Maria here. If this is not studying, that means this is studying. Or she could be put in here. I said I could put Maria in there. It just says Maria is not asleep. So she could be put here or here. So do you see, if Maria is worried, she will be studying. Um, I could put Maria here not studying, or I could put Maria here studying. If you could write it, if you could put dots in more than one location to disprove it, then the whole thing is not valid. I can put the dot in more than one spot, which makes this not valid. I mean, I could make it valid by putting the dot out here. Maria, she will be studying. It says she's not, not studying here. That means she's studying out here. But I could also put it in here because it says Maria's just not sleeping. So you have to look at the wording. These are the two things you have to write and then verify that this is true or not. And it's not valid because I could put Maria in more than one spot and it would be not valid then. So number 9 I'm putting down is not valid. Number 10, if it snows, school will be closed. Um, so if it snows, school will be closed. If it snows, I'm not sure if it snows. See, they don't have the argument for if. If it snows, school will be closed. We could also say all schools are closed if it snows. Same thing. So snows is up here, and I'm putting closed school. So if it snows, schools are closed. So that's the first one. We just did the first one. Now, if school is closed, in the school is closed circle, then Robert will finish his homework. Robert has to be inside the closed school. If school is closed, then Robert will finish his homework. That's Robert finishing homework. Finish homework. Therefore, Robert finished his homework. If it snows, school will be closed. If school is closed, Robert will finish his homework. I'm going to say that's valid. Robert finished his homework because school was closed and it snowed. That looks valid. I'm trying to figure out if I can draw that another way, and I think we're okay. Yeah, I have valid for that one. Let's look at the next one. These are tough, man. Even for teachers, these are really tough. You have to try to write these down. I know on the test we'll try to give you one that matches the wording from Euler exactly. All females are smart. Do you see? That's an Euler. The second part is always the big circle. Smart. All females. So I'm putting females inside smart. Do you see? The all females, if you look at Euler's, all A are B. All females are smart. Smart is the second letter is the big circle. The first letter goes inside of it. All females are smart. No females are president. So these are all females. These are, we could say no females has to be outside of the female circle. So I can have no females here, or I could put no females here. No females are presidents. So these are female presidents. They can't be, I mean, no females are presidents. So this is the president circle. We can call it the president circle, or we can put the president circle all here. On this side, presidents are smart. On this side, presidents are not smart. So we go either way. Do you see how I can write that both ways? Therefore, no president is smart. So they're saying, is this valid, female and president? Therefore, no, they're saying the presidents are not smart. This is smart. So they're saying, is this valid? Well, I can write this same statement. I can write this same statement like this. I can make some presidents smart, and here presidents are not smart. Do you see? By writing this, I had two choices, so it's not valid because I can change it. If I write it like this, it disproves no presidents are smart. In this case, a president is not female, but he is smart. So this is not valid because I can write it this problem more than one way, and I can disprove the statement that's there, the therefore statement. Whew. Are you guys getting this? Is it really, really confusing, or do you think you get it? I mean, the first two statements, you have to try to write the picture, and the therefore part, you have to see if it's valid or not. Can you write it a different way to disprove the validity? Number 12. By the way, this is on the and one of these is on the final. This one of these questions is on the final. If I work math problems, then I will be happy. Um, if I'm working math, I will be happy. Wait. I'm always happy when I work. Yeah, I think that's how we should write it. I was not happy, therefore I did not work any math problems. So happy is inside. It says I was not happy. So I have to put the dot outside of happy. Do you see? I can put the dot, I was not happy. I could put the dot in two separate spots. I could put it in here where I'm doing math problems, but I'm not happy, or I'm not doing math problems and I'm not happy. So therefore, I did not work any math problems. Do you see? I could put it here, and if I'm still not happy, I'm still working math problems. But if it was right here, then I'm not working math problems. So I can write it both ways. So this is not valid. If I can write it more than one way, if I did not work math problems, if I write it here, in here, I am working math problems. I'm not happy, but I am working math problems. So that's why it's not valid. Number 13. All students dislike finals. So dislike finals is the big circle. Dislike finals. And put all the students in here. All students dislike the finals. Leroy is not a student. So I could put Leroy here, or I could put Leroy here. Do you see? So he could dislike the finals, but if he's out here, he likes if the opposite of dislike is like. So he likes the finals. If I put Leroy here, he dislikes the finals. If I put Leroy here, he likes the finals. I have two different choices. So it's not valid. Those are easy ones when you can put them in two different spots right away. You can right away say they're not valid. All mammals are all whales are mammals. So you draw the mammal first, the second part of the statement, and then put the whales inside. A parrot is not a mammal. So I can put a parrot here. These are mammals. Sorry. A parrot is not a mammal. So the parrot has to go on the outside. These are mammals, and these are whales. A parrot is not a mammal. It has to be outside of the mammal circle. So a parrot is not a whale. That's true. Do you see? A parrot is not in the whale circle. So this is true. This is good. It's valid. That's a good statement. I mean, you can just say, "Oh, I know a parrot's not a whale," but you got to be careful. Like the word "pat," it could be male or female. There could be a parrot whale. So you have to draw those pictures. And that is the end of 6.8. Uh, Using Euler's diagrams, he's got four of them, don't forget. Um, Using the four Euler's diagrams um, to determine whether a statement is valid or not valid. These are the four Euler's diagrams that we talked about. All A's are inside B, No A's are inside B. Some A's are inside B. Some A's are not inside B. So these are the four. The one that says if is kind of like backwards what you normally do. The first would be on the outside, and then the other one goes on the inside. But concentrate on these four problems with these four. You'll have one of these like four. Usually the all A's are B. Problem like that will be on the test. So focus on these on the homework, and then when you look at the review, look at that. Um, this is Eulers. This is his logic of thinking on whether something is valid, a statement is valid or not. Are there any questions?